Hello, welcome to lesson 1 on the topic permutation and combination. The topic of permutation and combination plays a very important role as far as the competitive exams and campus placements are concerned. Fundamentally, this topic is very logical in nature, but a challenge with many of us happens to be the fact that we base our learning on this topic based on formulas. So before I begin the discussion on this topic, I would request all of you to please be logical while trying to understand and solve the questions on permutation and combination. So let us begin. When we talk about a topic like permutation and combination, the first thing that I wish to share with all of you, which I have to be clear about, is what is called as the fundamental principle of counting. Okay. Now, if you ask students a challenge that they would face in this topic, then many of them will share with you the fact that they are not very sure about the use of plus and multiply, that is the sign of addition and multiplication, while solving the questions of PNC. And that is where the understanding of the fundamental principle of counting becomes very crucial. So what is the fundamental principle of counting? Please listen carefully. The fundamental principle of counting says if a certain task can be done in m ways. So let me write this for you. If task 1 can be done in m ways, and after completing task 1, there is another task 2 that can be done in n ways. Okay, after completing task 1, there is another task 2 that can be done in n ways, then the number of ways in which task 1 and task 2 can be done together is m into n. This is the fundamental principle of counting. So what is the essence of the fundamental principle of counting? The essence of the fundamental principle of counting is something like this. If the concept in a permutation combination problem happens to be same as and, then the mathematical sign that you will be using is multiply. If the concept that you will be, the concept that you have in a question is same as or, then the mathematical sign that you will be using in solving the question is plus. So it is very simple. Whenever you are doing a question on permutation combination and you have a difficulty in deciding, you need to ask yourself this question. Is the concept same as and? Is the concept same as or? I repeat, if the concept is same as and, you will be using multiply. If the concept in the question is similar to or, you will be using plus. This, my dear friends, happens to be the basis of the entire topic of permutation combination, and this is popularly known as the fundamental principle of counting. Okay? So that is the beginning of our discussion on this topic. If you look at this topic, you will see that there are two things that have to be learned and discussed as a part of this topic. What are they? Permutation and combination. We would first like to start with combination. We would first like to get introduced to what is combination. Alright. Now combination in terms of logic essentially means selection only. That means in every question of combination, the primary objective is to select certain things out of a given set of things. Let us see this. Now we would like to introduce combination by saying that if there are n different things, if there are n different things and r things are to be selected, if there are n different things and r things are to be selected, then the number of ways of doing so is represented as NCR. I hope you all are listening carefully. If there are n different things and out of these n different things, r things are to be selected, then the number of ways of doing so is given by NCR. Alright, the C here representing combination. That means in essence we are only selecting. So it is primarily selection only. So it is NCR. And what is NCR? NCR is n factorial upon r factorial multiplied by n minus r factorial, where I'm sure all of us know this, but just in case you have any doubt, n factorial is the representation of the product of n into n minus 1 into n minus 2 and so on and going up to 1. So that is n factorial. Alright, so what is NCR? NCR is n factorial upon r factorial multiplied by n minus r factorial. Just to maintain continuity, I hope all of us are aware that 0 factorial, by definition, the way it is defined is 1. 1 factorial is also 1. 2 factorial is 2 into 1. 3 factorial is 3 into 2 into 1 and so on. Okay. So friends, students, if I have to select r things out of n different things, then the number of ways of doing so is NCR, and this is called as combination. Alright. Now let me take an example to further explain this to you. Suppose you have 4 different fruits, an apple, a mango, a banana and an orange. So 4 different fruits, and out of these 4 different fruits we have to select any 2. Alright, we have to select any 2 fruits out of these 4 different fruits. So what are the different selections possible? You can have apple mango, you can have apple banana, you can have apple orange, you can have mango banana, you can have mango orange, and you can have banana orange. Alright, so if I have to select 2 things out of 4 different things, then the number of ways of doing so, there are 6 different ways of doing so. If some of you are thinking, how about orange banana or orange mango, please understand the sequence here does not matter. So it is the which 2 fruits have been selected that is going to decide the total number of ways. So how many ways of doing this? There are 6 different ways of doing this. Alright. Now please appreciate that the total number of things available, 4, was a small value, and the number of things being selected was also small, and therefore it was possible to write all the possible selections. Okay, so what if the number of fruits become say 25, and out of those 25 you have to select 5 different fruits? I'm sure the total number of combinations can definitely be written, but the task is going to be very cumbersome and time taking. It is here that the concept of combination comes into play. Alright, now can I do the same calculation? Can I do the same calculation in a different way? Absolutely. That is what we had introduced as NCR. So let us try to do this in a different way. So what are we talking about? Are we talking about 4C2? Yes, we are talking about 4C2. So what is 4C2? 4 factorial upon 2 factorial into 4 minus 2 factorial. So 4 factorial upon 2 factorial into 2 factorial. How do we write this? We write this as 4 into 3 into 2 factorial upon 2 factorial into 2 factorial. How much is this going to be? This is going to be 6. Okay. So, if there are 4 different things, and out of those 4 different things, 2 things have to be selected, then the number of ways of doing so is represented as NCR, and that is what we have done here. Now I want all of you, if you pay a little attention, then you would know that invariably this calculation always, rather always this calculation will come to this point. Okay, and therefore can I do the same thing? Can I write this same thing in an easier way? Absolutely. So what is a shortcut, if you can call it that? What is the shortcut of doing 4C2? Start from 4 and write down the next 2 numbers. Start from 4, write down the next 2 numbers. Divide it by, start from 1 and write down the next 2 numbers. So that is how we can easily calculate the value of something like 4C2. Now the question is, can I do the same thing if I am talking about more number of things? Absolutely. Can we take an example? Definitely. Suppose we are talking about 11C3. Now, what is the logic of 11C3? Out of 11 different things, 3 things have to be selected. Out of 11 different things, 3 things have to be selected. What is the shortcut? The shortcut is 11 into 10 into 9. So start from 11, write down the next 3 numbers, divide it, start from 1, write down the next 3 numbers. So 15 into 11, what is the value of 11C3? The value of 11C3 is 165. That means if you have 11 different things, and out of those 11 different things, 3 things have to be selected, the total number of ways of doing so is 165. So that was the introduction to the topic of permutation and combination and the basic concept of what combination actually is. Thank you.